In this video, we're going to look at how to find the surface area of prisms and cylinders. In order to do this, we need to know some terms related to prisms and cylinders and what it means to be a prism or a cylinder. A prism is a polyhedron in which there are two parallel and congruent faces, and what we call those are the bases. So for example, this is a prism. The top and bottom look like squares, are parallel and congruent. This is called a right rectangular prism, by the way. This one is a right pentagonal prism. The right pentagonal prism has a pentagon at the bottom and a pentagon at the top, and so therefore there it is a prism, parallel and congruent faces, and we call those the bases. Now it's possible for a prism to also exist where it's not resting on its base like this. For example, if you think of a doorstop, it might look something like this. In which case the parallel and congruent bases would be on the left and right. So a wedge of cheese or a doorstop, something like that, is also a prism where the parallel and congruent parts are called the bases. Other terms you need to know are the height of the prism. The height of the prism is how tall it is. Now, if a prism is not a right prism, in which the lateral faces are perpendicular to the base, the height is still how tall it is. And I'll draw a picture of an oblique prism to show you that. This is going to be a prism because the top and bottom faces are going to be congruent and parallel, but it's sort of shifted. Still a prism, top and the bottom, these bases are parallel and congruent, but it's not a right prism because the angle formed by the lateral edges and the base is not a right angle. The height, however, is still the distance at a right angle between the two bases. So for this video, we're going to be focusing on right prisms and right cylinders and how to find the surface area of those. In order to find the surface area, we need to find the area of all the surfaces. Now, the way I like to do this is by drawing what's called a net for the shape. A net for the shape is basically taking this three-dimensional object and drawing all the 2D shapes that go into forming it. For example, this right rectangular prism has what looks to be a square at the bottom, a square at the top, and then 4 rectangles that go around. So a net for this figure would look something, or could look something like this. That'll be our top base, the longer rectangles that form the lateral faces, and there are 4 of those. And then I also need the bottom base. I could draw that here, I could really draw that on any of those. So this would be considered a net for that shape. For the right pentagonal prism, I've also got a net here. Here is the pentagonal prism. A net for it would be if I were to take this prism and sort of unfold it. So the prism, the net for this prism is the pentagonal base, the other pentagonal base, and then 1, 2, 3, 4, 5 rectangles that go around the outside of that shape, the lateral faces of the pentagonal prism. In order to find surface area, now all I have to do is find the area of the pentagons, there are 2 of them, and add it to the area of these 5 rectangles. If you want to find out more information about finding the area of the pentagons, take a look back at some older videos where I showed you how to find the area of regular polygons. As far as, of course, area of a rectangle, that would just be its base times its height. So for this one, it'd be 2 bases, 2 squares, would look to be squares, plus the 4 rectangles, length times width for each of those rectangles. So finding surface area of a 3D figure like this, of a right rectangular prism or a right pentagonal prism, or really any right prism, is just a matter of finding the area of the two bases and adding it to the area of the lateral faces, the sides that connect the two bases. And a cylinder usually seems harder for students, but in reality it's less work. Because if you think about a cylinder and what its faces look like and how many faces there are, there's actually less. A cylinder like this has a circular bottom, circular top, so our bases, instead of being squares or appearing to be squares and pentagons, our bases would be these circles. And then the lateral face is actually, I'm sure you've taken the label off of a can of soup before, or thought about that, just a rectangle. So if we were going to draw the net for the can or the cylinder, it would be the rectangular piece, which is going around the outside, the lateral face, and two circles. That was pretty evident. Get the idea. So in order to find the total surface area of the right cylinder, I would just have to find the area of the two circles and add it to the area of the rectangle. Now the area of any circle is found by doing pi r squared, and the area of any rectangle is done by doing the base times the height. Well, the height of the cylinder is the same as the height of the rectangle. The length of this, or the base of the rectangle, is really the same. I'll mark on this can here. I'll start that on one edge. And ended up right there. It's the distance around the can. And the distance around the can is the same as the circumference of the circle. So the base edge, the length of this, is simply the circumference of this circle, so therefore it's 2 pi r. So our area of the two circles, pi r squared plus pi r squared, plus the area of this rectangle, which is found by doing its base, 2 pi r, times its height. Alright, so that is just a summary of how you can find the surface area of a right cylinder by adding the two circles and the rectangle, which is the lateral face of that, the lateral area, which is again 2 pi r times the height of the cylinder. And right rectangular prisms, right pentagonal prisms, really any right prism, the way I would suggest doing that is drawing the net for the figure, which then shows you all of the different faces that you need to add together to find the surface area. You can look back again at other videos for how to find the area of regular polygons, and any rectangle we know is just the base times the height. Alright, so that's how you find the surface area of prisms and cylinders.